In part 1 of our lesson on sum and difference identities for cosine, we will derive and use the difference identity. To derive the difference identity for cosine, we're going to use some geometry and the distance formula. So first, let's consider points A, B, and D on the unit circle. Angle A is the angle in standard position whose terminal side goes through point A. Now we can actually determine the coordinates of this point because remember, when we are on the unit circle, the x-coordinate comes from the cosine of the angle and the y-coordinate comes from the sine of the angle. So that means over here at point A, we know the x-coordinate will be cosine A and the y-coordinate will be sine of A. Same for angle B. Angle B is in standard position and its terminal side goes through point B, which means the x-coordinate here will be the cosine of B and the y-coordinate will be the sine of B. Now, when we look at angle A and then subtract out angle B, we are left with this little piece of an angle here whose measure would be A minus B. What we're going to do is take that angle measure and rotate it around so that it is in standard position, and we're going to call the point on its terminal side letter C, so that the angle measure of C is exactly equal to the angle measure of A minus B. So then that means the coordinates of this point would be cosine of C, comma, sine of C, but C can be replaced with A minus B, so we can call this the cosine of A minus B, comma, sine of A minus B. Now, as I mentioned earlier, we're going to make use of the distance formula, and you remember that from your algebra class. We know that the distance between any 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, to get rid of that radical, we can square both sides and say then that the distance squared would be quantity x2 minus x1 squared plus quantity y2 minus y1 squared without the radical symbol. Now, we are going to want to remember a theorem from geometry that says congruent central angles intercept congruent chords. So let's see what that would mean in our picture. We know that the angle here that we're calling angle C, the central angle here, is exactly equal to the central angle here. So that means the chords that are intercepted by those angles are going to be equal to each other. So we have this chord is going to have to equal this chord, and we can mark those two as equaling each other. So we're saying that CD, which is here, has to equal AB, which is here. And now we're going to do some algebra on this and end up with the difference identity for cosine. So beginning with CD equals AB, we're going to square both sides so that we can get rid of the radical in the distance formula. So now we can plug into this formula because we're doing the distance squared. And from C to D, we have to do x2 minus x1. Now at letter C, the x-coordinate is cosine of A minus B, and we have to subtract away x1, which would be the x-coordinate of letter D, which is 1. And we have to take that quantity and square it. Plus, we have to do the y-coordinate at letter C, which would be sine of A minus B. And we have to subtract away the y-coordinate of point D, which is 0. And then we have to square that quantity. So this left-hand side is just the distance formula applied on CD. Next, we have to apply the distance formula here, the squared version, from point A to point B. So the x-coordinate of point A is cosine A. We have to subtract the x-coordinate of point B, which is cosine B, square that quantity, plus we have to take the y-coordinate of point A, which is sine A, and subtract the y-coordinate of point B, which is sine B, and square that quantity. Multiplying all this out is going to take a little bit of space, so we're going to do this one first and put it on its own row, and do this one second and put it on a row underneath of it. We know how to take a binomial and square it. This is going to become cosine squared of A minus B minus 2 times the cosine of A minus B plus 1. Now this one's pretty easy because since we have a 0 there, all we have to do is square the sine of A minus B, so we will get plus sine squared of A minus B and this whole thing has to equal the right-hand side. We'll square out this first binomial and put it in the top row, square out this second binomial and put it in the next row. So this is going to become cosine squared of A minus, we have to double the product, 2 cosine A cosine B plus cosine squared of B. Plus, we have to square this binomial, so we're going to get sine squared of A minus 2 sine of A sine B plus sine squared B. All right, now we can use a Pythagorean identity right here. We know that cosine squared of anything plus sine squared of the same anything is equal to 1 by the main Pythagorean identity. We will bring down the rest, which is minus 2 cosine of A minus B plus 1. And that has to equal the right-hand side, which we see we get to use a Pythagorean identity again here. Cosine squared of A plus sine squared of A is equal to 1. Now these two rows are not like terms, so we just have to bring them down. We've got minus 2 cosine A cosine B minus 2 sine A sine B. And then here we get to use the Pythagorean identity again, because cosine squared of B plus sine squared of B is going to equal 1. So on the left-hand side, we have a 1 plus a 1. We can write that as 2 minus 2 cosine of A minus B. On the right-hand side, we have a 1 plus 1, which gives us 2. And then I notice I've got a minus 2 here and a minus 2 here in these two terms. Let's factor out minus 2 times, this would be cosine A cosine B. Now be very careful of your signs here. Since we factored out a negative, we are going to have to put plus sine of A sine of B. Right? If we double check this now, if we take negative 2 times cosine A cosine B, there it is. Negative 2 times sine A sine B, there it is. We see we can subtract 2 from both sides, and it would simplify to be negative 2 cosine of A minus B is equal to negative 2 times the quantity cosine A cosine B plus sine of A sine of B. The next step would be to divide both sides by negative 2, and we get cosine of A minus B is equal to cosine A cosine B plus sine of A sine of B. And this is what we call the difference identity for cosine. And what this gives us is a mechanism for finding the cosine of the difference of two angles. Notice that the cosine function is not distributive. It does not work to say that the cosine of A minus B would be cosine of A minus cosine of B. That will never happen. What does work is to say that the cosine of A minus B is the cosine of angle A times the cosine of angle B. Then you have to add to that the sine of angle A times the sine of angle B. So let's take a look at how this works. In this example, we have to find the exact value of the cosine of pi over 12. Now, pi over 12 is not one of our special angles, so until we had this difference identity, it would have been impossible for us to find this exact value. Now, what we have to do is write pi over 12 as the difference of two angles that we do know the trig function values for. So for example, we know the trig values for pi over 6, pi over 4, pi over 3, etc. Those are the ones we know. And if we give all of these a denominator of 12, we know pi over 6 would be 2 pi over 12. Pi over 4 would be 3 pi over 12. Now, if we were to subtract 3 pi over 12 minus 2 pi over 12, we would get 1 pi over 12. So we can write the cosine of pi over 12 as equaling the cosine of pi over 4 minus pi over 6. Because remember, this was 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. Now what we're going to do is apply the identity, which says you have to take the cosine of the first angle, which in our case is pi over 4, times the cosine of the second angle, pi over 6, and you have to add to that the sine of the first angle, so pi over 4, times the sine of the second angle, pi over 6. Now we know all of these values. The cosine of pi over 4 is equal to radical 2 over 2. The cosine of pi over 6 is radical 3 over 2. The sine of pi over 4, radical 2 over 2. And the sine of pi over 6 is 1/2. So this first product will be radical 6 over 4. The second product is radical 2 over 4. Because they have a common denominator, we can write them as one rational expression, radical 6 plus radical 2 over 4. And that is our solution. So now, using a difference identity, we're able to find the cosine of pi over 12 when we couldn't before. But it's because we can write pi over 12 as pi over 4 minus pi over 6, and then apply the identity. In this next example, you have to find the exact value of cosine of 165 degrees. So our goal is going to be to write this as the cosine of the subtraction of two angles whose sines and cosines we do know. And in this case, you'll use degree measure angles. So think your way around the unit circle and try to find two angles that would subtract to be 165, and those two angles have to be angles that we know all the trig function values for. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. Now you could use any two angles going around the unit circle. So whichever angles you used, you're going to get the same answer as I will, even if you used different angles that subtract to be 165. For example, we could have done 225 degrees minus 60 degrees. And now we would apply the difference identity for cosine, and we get that this would be cosine of 225 degrees times cosine 60 degrees plus sine of 225 degrees times sine of 60 degrees. Next, we fill in all the values. We know the cosine of 225 is negative radical 2 over 2. Cosine of 60 is 1/2, plus the sine of 225 is negative rad 2 over 2 times the sine of 60, which is radical 3 over 2. Now, when we multiply these fractions, we can see our denominator will be 4. When we multiply these fractions, we see the denominator will be 4. So let's just go ahead and write that denominator is 4. The numerator of this first product will be negative radical 2, and the numerator of this second product is negative radical 6. So we put a minus radical 6. And this is the exact value of the cosine of 165 degrees. Now, you may have used different angles. You may have said 210 degrees minus 45 degrees, but you're going to get this same answer. Your answer may have come out to be negative radical 6 minus radical 2 over 4, and of course that answer would be equivalent with this one. So the order of these two wouldn't matter since they're both negative.